Imagine two people alone in a vast desert wanting to communicate. They need a common language and a way to transmit messages. This is what the point-to-point protocol, or PPP, does for computers. In the vast expanse of computer networks, PPP acts as a direct line, enabling two devices to talk. It doesn't matter if they speak different network languages, PPP bridges the gap. Think of dial-up internet. That familiar sound of a modem connecting is PPP in action. It's how your computer, once upon a time, used telephone lines to access the internet. But PPP isn't stuck in the past. It's still vital today for secure connections like those used in some virtual private networks, VPNs, and even in high-speed fiber optic networks. PPP's strength lies in its simplicity and versatility. It's like a universal translator for network devices. Whether it's a computer talking to a router or a server connecting to a remote network, PPP ensures smooth and reliable communication. In essence, PPP is the unsung hero of countless internet connections. It works tirelessly behind the scenes, allowing us to connect, share, and explore the vast digital landscape. Now let's peek under the hood of PPP. Imagine PPP as a well-organized workshop, with each component playing a crucial role. First, we have the encapsulation component. This is the packaging department, taking data and wrapping it neatly into PPP frames, ready for delivery. Then comes the link control protocol, or LCP. Think of this as the foreman, responsible for setting up the communication link. LCP negotiates the ground rules, things like how big each data packet can be, and whether any data compression should be used. Next, we have the authentication protocols, our security guards. They verify the identities of the devices trying to connect, ensuring that only authorized parties can communicate. Two common protocols are PAP, like a simple password check, and CHAP, which is more like a secret handshake, making it much more secure. Finally, there's the Network Control Protocol, or NCP. This is our translator, ensuring that devices speaking different network languages can understand each other. NCP configures the network layer, allowing data to flow seamlessly between the two connected devices. Imagine a PPP frame as a digital envelope. Just like a physical envelope has a specific structure, so does a PPP frame. Each part ensures data is delivered reliably and securely. The flag marks the beginning and end of the frame. The address indicates the frame's recipient. Often it's a broadcast address for any device on the link. The control field has special handling instructions. The protocol field identifies the data type. A PPP frame can carry different types of network data. The data field contains the actual message. This is like the letter itself. The frame check sequence is like a seal of authenticity. It verifies the data arrived intact. Section 4. Establishing connections, how PPP works. Alice and Bob want to share messages using PPP. Alice sends a signal to Bob, initiating a connection. Bob responds, establishing a direct link. Their LCPs negotiate communication terms. They agree on message length and compression. Authentication protocols take over. With PAP, Alice tells Bob a password. With CHAP, they use a challenge-response handshake. NCPs ensure they understand each other. They agree on a common network protocol, like IP. Alice and Bob start exchanging messages. Messages are packaged into PPP frames. The FCS ensures error-free messages. They send closing signals terminating the connection. Section 5. Advantages and applications of PPP. PPP's enduring popularity stems from its many advantages. Its simplicity makes it easy to implement across a wide range of devices and connections. Yet it's also remarkably versatile, supporting various network protocols and configurations. One of PPP's key strengths is its focus on security. Authentication protocols like CHAP protect against unauthorized access, while encryption options add an extra layer of protection for sensitive data. PPP also helps optimize network performance. Its compression capabilities can shrink data packets, allowing for faster transmission speeds, especially over slower connections. Error detection mechanisms ensure reliable data delivery, minimizing the need for retransmissions. From dial-up internet to dedicated leased lines, PPP finds applications in diverse networking scenarios. It's used in connecting remote offices, establishing secure VPN connections, and even in mobile phone networks when connecting to the internet. In conclusion, PPP is a testament to the power of elegant design in networking. Its simplicity, security, and flexibility have made it an indispensable tool, quietly enabling countless connections in our increasingly interconnected world.